Join me as I dive into the mind-bending concept of black holes and challenge myself to figure out if they can actually warp time to the future. Black holes are essentially regions of space-time where gravity is so strong that nothing, not even light, can escape once it gets too close. The theory goes that black holes are so dense they warp the fabric of space-time around them, creating a gravitational pull so strong it's like a cosmic sinkhole. But what's really fascinating is that according to Einstein's theory of general relativity, black holes have the potential to warp time itself. The question is, can they warp time to the future? One of the most common misconceptions about time travel and black holes is that you can simply jump into a black hole and emerge at a different point in space and time. Unfortunately, it's not that simple. The laws of physics as we currently understand them suggest that if you were to approach a black hole, you'd be stretched and squeezed by the intense gravity, eventually getting torn apart at the molecular level. Not exactly a pleasant way to travel through time. Another misconception is that black holes are like portals to other dimensions or parallel universes. While it's true that black holes do warp space-time in extreme ways, there's no scientific evidence to suggest that they're doorways to other realities. The universe is a complex and mysterious place, but we need to be careful not to get too carried away with our imaginations. The idea that black holes can be used for time travel also raises a number of paradoxes and logical inconsistencies. For example, if you were to travel back in time and kill your own grandfather before he had children, that would mean you were never born. But if you were never born, who killed your grandfather? It's a classic catch-22 situation. The laws of physics need to be consistent, and time travel through black holes raises a lot of questions that are still unanswered. The biggest challenge, however, is the sheer energy required to create a stable wormhole or warp bubble that could transport us through space-time. We're talking energies that are far beyond our current technological capabilities, and even if we did manage to create such a bubble, it's unlikely we could survive the intense gravitational forces and radiation near a black hole. According to general relativity, massive objects like black holes warp space-time by creating a curvature that affects the flow of time. The closer you get to a black hole, the slower time moves relative to the outside universe. This effect, known as gravitational time dilation, has been observed and confirmed in the real world. For example, GPS satellites need to account for the effects of gravitational time dilation to maintain accurate navigation. The theory of general relativity also predicts that if you were to approach a rotating black hole, you'd experience what's known as frame dragging. The rotation of the black hole would create a kind of drag on space-time, causing it to twist and rotate along with the black hole. It's a mind-bending concept that challenges our classical understanding of space and time. One of the most fascinating implications of general relativity is that it suggests the possibility of closed time-like curves. In other words, it's theoretically possible to create a loop in space-time where you could travel back to a point before you started. However, creating such a curve would require an enormous amount of energy, and it's still unclear whether it's possible in practice. The concept of closed time-like curves raises an interesting question. Could black holes be used to send information to the past? Again, this raises a number of paradoxes and logical inconsistencies, but it's an area of active research in theoretical physics. If we were able to harness the power of black holes to travel to the future, it would have major implications for our understanding of the universe. We could potentially learn about the fate of the cosmos, discover new forms of life, or even make contact with advanced civilizations. The possibilities are endless, and it's an exciting area of speculation. In conclusion, the relationship between black holes and time travel is a fascinating and complex one. While there are many scientific challenges to overcome, the theoretical possibilities are endless, and it's an area of research that continues to capture our imagination. Thanks for joining me on this journey into the mind-bending world of black holes and time travel. If you have any thoughts or theories about time travel, be sure to share them in the comments below. And if you're interested in more mind-bending concepts, be sure to check out my video on time travel theories.